This video, I'm going to go over the midterm exam results a little bit in case you have some questions. The test average was 83, which is decent enough. The test scores range from a 50 to a 100. Kind of a general comment, some of you clearly cut and paste answers from somewhere, the book somewhere, don't know. And I was surprised by that. I mean, I didn't really go crazy on penalties on that, but that's never okay. It's never correct to cut and paste an answer on any kind of a test. So a lot of these questions, I'm looking for your understanding of the topic, not something from the web. Okay, so let's make sure on the final that we don't do that. I will make it clearer in the question that, you know, in your own words. I didn't think I needed to add that, but apparently I did. So again, it's open book, open note. You're welcome to look at anything that you want, but you need to turn it into your own words so I can understand what it is. So I can make sure that you understand the material. That's the point, okay? So let's go through these questions quickly. So what's an algorithm? The big thing there is the word unambiguous. So if you didn't say that, I may have just said in the comment unambiguous, which is probably pretty ambiguous, sadly. But algorithms have to be a step-by-step way to solve a problem, unambiguous, lots of things that you can say there. Same thing for pseudocode. Pseudocode's a good way because it's independent of any language. It's unambiguous. It's not like natural language, which can have multiple meanings. Lots of things you can say there. And then what other ways could you express it? You could do it through a flow chart. You could do it through structured English. You could write a program. Lots of answers there, okay? So on the creating the brute force algorithm in pseudocode, some of you didn't have it in proper pseudocode form, so that cost some points. A lot of you, oddly enough, did a sorting algorithm, which does in fact find the largest element in kind of a roundabout way, but your algorithm needed to return that largest element. Some of them did, and that's fine. The efficiency of that, if there are the two loops there, would be a big O of n squared or quadratic. Some of you got that wrong. Some of you didn't put it what the efficiency was at all. The normal way to do it is what I would call the king of the hill algorithm, where you set the largest to be the first element. You go through every element to see if it needs bigger, so you switch that value, which is a linear or big log of n. Okay. Someone had said that that's constant because you know based on n how many times it's going to execute, and constant doesn't work that way. Constant means that the answer is independent of how many elements there are. Okay, so that's kind of a different way to look at that. Okay. Difference between brute force algorithm and divide and conquer algorithm. The basic idea there is that brute force takes the most direct approach and just touches every element as many times as it needs to. There's no pizzazz. There's no trying to be fancy. Okay, you have no technique at all. Just get in and do it. Okay. Some people said that the brute force has an efficiency of n squared or quadratic, and it just doesn't. I mean, it's a category of algorithms. There are algorithms that are brute force that have a wide variety of efficiencies. Okay, so it's not that's not correct. Okay, divide and conquer. You're going to divide up a problem into two sub problems, hopefully of roughly the equal size. You keep doing that, and then you have to put the things back together. Again, it does not have a guaranteed efficiency of n log n. Some do, some don't. Okay. 4, explain merge code, not in pseudocode, but in just words. Okay, so I didn't want to know what it was. If you said that merge sort is a divide and conquer algorithm for sorting, that was not enough. I want to know the mechanisms that you break the list up into half and then recursively keep doing that and then merge it back together. Okay, the average efficiency is n log n. Quick sort, same thing. Some of you must have read somewhere that it's based on the values, not the position, because several of you said that, and I don't know what that means exactly. When you're sorting, you're always based on the value, which is at some position. So I'm not sure where that was going. And some of you said that you talked about the partitioning, but you didn't say how you then sorted it. So a partition's not a sort. So with quicksort, you partition it, and then you sort what's left over, basically. There has to be some sorting there, okay? And the same thing for heap sort. Heap sort, for a full answer, you need to explain what a heap is. A heap is not a binary search tree. A heap is a binary tree, okay? It's essentially complete. and has a parental dominance. Say that quick and you're good. If you just described a heap and not how to use that as a sort, that didn't work either for full points, because once you have a heap, you return the biggest element from that, okay, and then reheapify the rest to keep doing that, okay. 7, on how would you determine which sorting algorithm to use, okay. So there's a lot of things you can go here, okay. That's separate from the other two questions. So in general, you have to look at the size of the input. You have to look at the kind of input you have. You have to look at the computing resources at your disposal. You have to look at if there are any time requirements on your code, okay? So you would use something like selection sort. It's simple to implement. It's simple to do, simple to look at. If you didn't have a lot of data or you didn't have any time restraints, okay? Pros and cons, I literally wanted pros and cons for merge sort, quick sort, and heap sort, okay? So yeah, if you didn't give me all that, then it was going to cost you some points, okay? The brute force method on the closest point problem on problem 8, okay? Some of you, and I didn't specify, so I didn't count off, some of you assumed we were in one dimension, like on a number line, and that technically is correct. That makes it an easier algorithm. But again, I wanted the overview here. So I wanted you to say something like that with the brute force, you just look at every pair of points and calculate the distance for all of them. You can talk about ways to make that a little better to make sure you don't test the same line twice, but you don't have to do that. And that's it. You're just going to solve them all. I didn't ask about the efficiency, so you don't care. Okay. The divide and conquer is the one. A lot of you got this correct, but missed one little thing. That's where you divide it up. You look at the median point of X values. You divide it up into 2 sections. You then get all of the points in those 2 sections, those 2 halves. Find the smallest for each one, whichever the smallest one. Okay, that's your minimum distance. But you have to check the gutter. So if I said check the gutter in the video or in your comments, what I'm talking about is you have to look at that D minimum distance on either side of your median line to make sure that there are not 2 points in there that cross that between one group to the other that are shorter than the ones that are further away, okay? And we talked about that in the video. So you lost some points if you didn't have that last little part, okay? Number 10, using the bottom-up method to turn the following list into a heap. Okay, for that, when you turn it into a tree first, the 5 as the root, the 7 to 9, then the 2, 4, then the 12, 8, and the 1 to the far left. Okay, then you go through and basically enforce that parental dominance. And when there's a change, you have to do that again. Okay, and then give the final result in array form. A lot of you got that correct. Some of you didn't show your work, which cost you some points. And some of you kind of went off the rails on that one for whatever reason. Okay, so all of the grades are posted, should be out there. If you look through that and have any questions, then make sure that you let me know. Okay, we'll have, this is Thursday when I'm recording this, so we'll also be able to talk about this during office hours today if you want to do that.